Okay, so here I want to look at square roots to start. And we talked before about taking a square root and simplifying it. But if we want to add square roots together, if you have the same number inside the root, this is like adding 5x and 2x together, or 5x minus 2x. If the number inside the square root is the same, you're just simply adding or subtracting the coefficients. If it's not the same, so if you have something like 2 root 75 plus 5 root 12, we cannot add these together. But if we were to take the square root of 75 and simplify that, you're going to end up with 5 root 3 as another way to write the square root of 75. So then 2 times 5 would be 10, and now you have a 10 root 3. When you take the 12 breaks into 2, 2, and 3. So another way to write 12 would be 2 root 3. This 5 just comes down. This is also going to be, because it's 5 times 2. And now I have common terms. You can only add them together if you have common terms. If at the end, this had been 10 root 3 plus 5 root 7, then this would have been my simplified answer. There's nothing else I could have done with that. So the key when you're adding and subtracting radicals is to put them in the simplest possible form and then only combine like terms. Well, what if we're talking about multiplication? So for multiplication, what if we have something like 5 root 2 times 3 root 15, we'll say. Well, the first thing I suggest is take the 5 and the 3, put them off to the side, and you have 15. Then we're just going to focus on the root 12 and the root 15. Well, I know when I take 12 down and break it down, 12, prime factorization of 12, is 2 times 2 times 3. The prime factorization of 15 is 3 times 5. Well, the square root of 2 times 2 is 2. The square root of 3 times 3 is 3. And the 5 is left over. So this ends up just being, when I multiply those all together, 90 root 5. And this is all stuff that we would have seen back in Algebra 1. What I definitely want to spend some time with is, what if we have a scenario like this? So 5 plus root 2 times 3 minus 2 root 2, we'll say. And this is my FOIL method. So if I have this scenario, it's just like if I had x plus 5 times x plus 3. So I'm going to multiply 5 times 3. I get 15. Root 2 times 3 is just simply 3 root 2. Can't do much with it. 5 times negative 2 root 2 is negative 10 root 2. And I'm going to write it down here so my like terms are together. And now when I take the root 2 and the negative root 2, and I'm going to do this down the very bottom, if I took the square root of 2 and multiplied it by negative 2 root 2, well, these two together is basically going to be the square root of 4. So this ends up being worth negative 4 down here. And we could spend more time looking at that a little bit later. So that basically means there's a minus 4 on the back of this. And that's just simply the square root of 2 times the negative 2 root 2. So that's going back to the algebra stuff. Well, now, 15 and negative 4, 3 root 2 and negative 10 root 2, and I'm set. So that's the introduction to this. The thing that I want to be able to focus on tomorrow is, what if we have something like 3 root 15 over the square root of 6. First thing we want to do is ask ourselves, are the numbers inside or the numbers outside, are they simplifiable? In this case, they both share a 3. So the first thing I'm going to do is turn this into 3 root 5 over the square root of 2. That's the first thing I'm going to do. I'm going to factor a 3 out of the top and bottom and cancel them out. Now I have to what's called rationalize the denominator. So I'm going to multiply the bottom by the square root of 2 and the top by the square root of 2. It is whatever is right here. And the reason I do root 2 over root 2 is because any number over itself has a value of 1. And now I'm going to put this together, which gives me 3 root 10 because there's no commons. The square root of 2 times the square root of 2 is 2. And I've done what's called rationalize the denominator. And these are the things that I want you to check out. We can spend some more time with this tomorrow and ask whatever questions you have.